All right, hey everybody. Let's talk about this lab that we just did. So, why did we do this lab? What was the point? Well, someday I want you to, if you see a chemical reaction out there, I want you to be able to point to it and say, hey, that's a chemical reaction. And if someone asks you, how do you know that that's a chemical reaction? I want you to be able to explain how you know it's a chemical reaction and convince them that it's a chemical reaction. So the very first thing that we did in this lab, before we put on our safety glasses, before we got our copper wire, was we found definitions for these very important science words. So what's the difference between physical properties of something and chemical properties of something? Like the physical properties of copper, or the chemical properties of copper, for instance. Well, the properties of something is how you would describe it, right? How would you describe copper? Maybe you'd describe it as kind of an orange color, shiny, metallic looking. Maybe you would describe the copper wire as thin. But what are the differences between physical properties and chemical properties? Physical properties can be observed or measured without having to pour chemicals on the substance and see if there's a reaction. So you can just look at something and determine its physical properties sometimes. Things like color, shininess, maybe. Is something solid? If it's a pure substance, is it solid at room temperature? Is it liquid at room temperature? But not all physical properties are visual. For instance, one of the physical properties of a substance is its melting point and its boiling point. So if we took some copper and we put it on a stove and we heated it up slowly and had a thermometer on there so we knew exactly how hot it was, we'd find that copper always melts at exactly the same temperature. And that's one of its physical properties. So then what's a chemical property then? Well, a chemical property is, let's pour some chemicals on this thing and see if there's a reaction. And you can't determine the chemical properties of something unless you mix it with other substances and see how it interacts. Can I tell just by looking at this copper? Can I tell, oh, I think it looks like if I put it in silver nitrate solution, it looks like there'd be a reaction. Can I tell that? No, I can't tell that. The only way to tell if there's going to be a reaction between copper and silver nitrate is to mix some copper and silver nitrate and see if there's a reaction. And if there is, then that's one of the chemical properties of copper. You can say copper reacts with silver nitrate. But what if there is no reaction? What if you dip copper into the silver nitrate and nothing happens, and you leave it there for days and nothing happens? Is that a chemical property of copper? That nothing happens? Yeah. Yeah. If you know that copper and silver nitrate do not react, that's useful information. All right. The first thing we did was get some copper wire, and you were supposed to describe the copper wire. How did you describe it? Did you describe it as orange colored, shiny, metallic looking? Are these physical or chemical properties of copper? Well, you probably said physical. But can you explain your reasoning? Can you tell me why it's a physical property? Can you prove to me that it's a physical property? Can you convince someone else that it's a physical property? A lot of times we know the right answer, but we have a hard time explaining why that's the right answer. Well, if something fits a certain definition, then it is that thing. And what's the definition of a physical property? A physical property is something that can be observed or measured without having to pour chemicals on it, right? So these things, the color and the shininess, those are things that can be observed without pouring chemicals on the copper. So look at the way I explained it here. Do you think if you explained it the way I explained it, you think you'd get an A on the quiz? All right, next we rubbed sandpaper on the copper wire. Why did we do that? Well, I told you to do that because I was worried there might be something on the copper wire that would prevent the chemical reaction from happening. And why was I worried about that? Well, have you ever eaten an avocado or half an avocado and put the other half in the fridge for a day? When you came back to it the next day, what was different about it? Probably turned to brown, right? Now they say that avocados taste the same when they're brown like that, but I've never been brave enough to eat a brown avocado, so I don't know. But why does that happen? Is that a physical change or a chemical change? It's a chemical change. There's oxygen in the air. The oxygen molecules are getting on that avocado and they're reacting, and they're actually changing the particles in that avocado. They're turning into oxides. And copper does the same thing. If you leave copper sit out, the oxygen molecules will get on that copper and do some chemical changing, and the copper will be covered in oxides. Now, do you think that could be a problem? If we want to see what happens when copper and silver nitrate meet, do you think that's a problem if the copper is completely covered or coated in oxides? Absolutely. So we took some sandpaper, got those oxides off of there, so that when we put it in the silver nitrate solution, it would be copper, pure copper atoms touching silver nitrate. When we did the sandpaper, was that a chemical change or a physical change? Again, it's pretty obvious that it's a physical change, but can you explain how you know that it's a physical change? Could you convince someone else that it's a physical change by explaining to them what a physical change is? Well, again, the definition helps us out here. In a physical change, there's no new substances. The particles don't change. We had copper particles at the beginning, and we had copper particles at the end. So it's not a chemical change, therefore it must be a physical change. On the first day of our lab, I told you that we were using weak silver nitrate solution. We were using 0.1 m AgNO3. But then the second day I came back and I said that I made it stronger. I added some silver nitrate to make it 0.15 m AgNO3. And I'm glad I did, because the crystals that we got were much cooler with the more concentrated silver nitrate. So what do you think M means in this case? It means molarity. It means, but what does that mean? Molarity refers to the concentration of something. And it's called that because we tend to measure chemicals in a unit called moles. So 2 moles, if you add 2 moles of something like copper, 2 moles of copper, would be twice as much as 1 mole of copper. All right, so when you saw the aqueous silver nitrate for the first time, what did it look like? What were its physical properties? Probably said it was colorless or clear. Did you happen to waft it? Did you smell it? It's okay if you didn't. But you probably noticed it doesn't have much of a smell. Is that a physical property? Yeah, physical property, or what we call odor, is a physical property. Sorry, did I say that right? Smell is a physical property, or what we call odor is a physical property. Now, sometimes when you're doing a chemical reaction, you'll mix 2 things together, and all of a sudden there'll be a new smell. Is that evidence of a chemical reaction or a chemical change or a physical change? Smell is a physical property, but if you get a new smell, that's an indication that you made a new substance. And that smell is just a physical property of that new substance. So if you have a new substance, then you have a chemical change, right? I hope you got that. I don't remember if I told you, how did I take the 0.1 molar silver nitrate? How did I make it 0.15 molar silver nitrate? Well, all I did was add some more silver nitrate powder. You see, silver nitrate solution is just made by taking some distilled water, and distilled water is just like pure water. Just water molecules. No salts, no minerals, no chlorine, nothing like that. Just water molecules. And you add some silver nitrate powder to that. And the silver nitrate powder dissolves in the distilled water. So, which one is the solvent? The distilled water or the silver nitrate powder? The water, right? The water is the solvent. So if the water is the solvent, which one is the solute? The silver nitrate powder, right? The solvent does the dissolving. The solute gets dissolved in the solvent. Do you think you better know that for a mastery check? All right. So one thing we cannot say about silver nitrate solution, now that we know that silver nitrate solution is two substances, right? If we zoomed down and looked at the particles, we would see water molecules, and we would see silver ions, and we would see nitrate ions. So now that we know that it's a mixture, right? So what kind of mixture is it? A heterogeneous mixture or a homogeneous mixture? Think about the definitions of those things. It's a homogeneous mixture, right? Because in a homogeneous mixture, you can't see where the water ends and the silver nitrate begins. You can't see any silver in there, you can't see any nitrate in there. It just looks like one thing. Here's an example of a good explanation for that. Okay, as you read my answers, pay attention. I want you to write like this. I want you to talk like this. All right, hopefully you weighed your stuff. I had an alarming number of people that got to the end of the lab and asked me, what does record the mass mean? And I said, it means weigh your stuff. You weighed your stuff before the experiment, right? And they said, no. If you're supposed to get the mass of something, you need to put it on the scale and figure out how much it weighs. You're supposed to take the mass at the beginning before you added the silver nitrate to the copper and added it to the beaker. And you're supposed to get your mass one more time after you wrote all your observations. All right, so you did the experiment and hopefully you noticed some changes. What kind of changes did you notice? Most people noticed that the copper turned black first, and then little white crystals started growing on it. And they grew and grew and grew, and hopefully over time you saw that they grew larger. And over time you probably also noticed that the water turned kind of a blue color. Why do you think that is? Is that evidence of a chemical change or a physical change? Here's an example of some observations you might have made. Did any of you write down the time that you started the experiment? A lot of people didn't. I was surprised. For something like this, it's a good idea to write down the time that you started. And that way, if you forget what time you started, you can just look at it because you wrote it down. You were supposed to take your observations 3 minutes after you started, 6 minutes after you started, 9 minutes after you started, 12 minutes after you started, and 15 minutes after you started. All right, hopefully you followed the cleanup procedures. You've seen what silver nitrate does to copper, and guess what water pipes are made out of? Copper. So I hope you didn't pour any of that liquid down the drain. I hope you poured that liquid in the funnel that I provided for you guys. A big part of this lab is just writing down what you observe. That's so important for scientists to write down what they see. In the professional science world, scientists will do an experiment like this, and then they will share their observations with other scientists. And other scientists should be able to read what you wrote and read your descriptions, and they know what happened without actually having to do the experiment themselves. So you want to be as descriptive as possible so that someone can just imagine what you did exactly and imagine what you observed exactly. All right, hopefully you took a crack at those post-lab questions, but there were some things that we've never talked about in there, so let's talk about them. Number one, is there evidence a chemical reaction occurred? What evidence do you have to support your decision? Yeah, there's evidence a chemical reaction occurred. So if there's a chemical reaction, then we're getting some sort of new substance, some sort of new particle. And if there's a new substance, what are we going to see? We might see a new color. Did we see any new colors? The blue, right? Did we see, sometimes you might smell something new, right? Because that's a physical property of substances. And also those crystals. You know, we started out with copper and clear liquid, and we got those shiny white crystals. So that's also evidence that we've got something new. Look at your definition of the law of conservation of mass. Does your data support this law? Hopefully it does. The law of conservation of mass says that you always have the same amount of stuff at the end as you had at the beginning. Did you have the same amount of stuff at the end as you did at the beginning? How can you know? That's why we weighed it, right? Weighing it will tell you how much mass there is at the end and how much mass there is at the beginning. So your two measurements, your two numbers, should have been exactly the same. That doesn't mean they were, but they should have been exactly the same. And scientists who do these experiments very, very carefully have found that they always get the exact same thing at the end as they do at the beginning. People who don't get the same thing, it's usually because they spilled some, or they put something in water and there's still a little bit of water sticking to it, so it adds a little bit of mass. But people who are very, very careful always find the same amount of stuff at the end as they do at the beginning. And that's why we believe in the law of conservation of mass. And if you don't have the same amount of stuff at the end as you do at the beginning, you got to ask yourself, where's this extra stuff coming from? Or where did the stuff go that I can't find? All right, you began with copper wire and aqueous silver nitrate. What do you think that stuff was? Those little crystals that formed in the beaker. What do you think that was? Started out with copper and silver nitrate dissolved in water. What do you think those silver crystals were? Well, did any of you say silver? Like metallic silver? Like we started out with metallic copper. Did any of you think that that was metallic silver that was forming on that copper wire? I mean, we've got a bunch of silver in the liquid. Maybe it's just collecting on that copper wire or concentrating. And actually, that's exactly what's happening. What's happening is the nitrate ions would rather be with the copper ions. So they're pulling, they're giving up the silver, and they're pulling, or they're grabbing up all of the copper ions. So the copper ions are going onto the nitrate ions. And then what are the silver ions going to do? What do? They've been abandoned by their nitrate partner. Well, they all start finding each other and collecting on that copper wire. So we knew there was silver in there. And the crystals look kind of silvery. So it just makes sense. Is the copper wire still intact? Well, yours probably was intact. Or it looked like it was intact at the end of the 15 minutes. People who left theirs overnight found that the copper wire broke off. Now, is the copper wire still intact? Well, if the nitrate ions are pulling copper ions out of the wire, then I guess the copper wire is not really intact, is it? A lot of the copper particles have already been removed. So scientifically, you have no way of proving this, but I have a degree in chemistry, so I know that the copper particles have been pulled out. So no, it's not really intact. What do you think happened to the liquid to turn it blue? I think I might have already said this, but those copper ions are in the water now. Instead of being in the wire, they've been pulled out into the water, into the silver nitrate solution. And it turns out that when you have a bunch of copper ions dissolved in water, the water looks blue. The bluer it is, the more copper ions you have. And we know that from doing other experiments with copper. I mean, the scientific community knows that from doing other experiments from copper. And now you know it. All right, in words, express the chemical equation that represents the reaction that occurred. So we haven't talked about chemical equations yet, but there's kind of like, you've seen math equations where you write 2 + 2 = 4. It's a quick way of writing down math problems. And in chemistry, we do the same thing. We have a quick way of writing down chemical reactions. And we start by writing the reactants on one side, separated by a plus sign. We say we take this thing and put it together with this thing. And then there's an arrow, and that says that there's a chemical reaction. And then the things on the right side, the products, that tells us what we get out of the reaction. So what would the reactants have been in this experiment? Did you say copper and silver nitrate? I hope you did. And we had copper and silver nitrate, and they reacted, and there was some switching. The particles changed. The atoms in the particles changed. And what were the particles that we got out at the end? Silver particles and copper nitrate particles. So the silver and the copper just switched places. And then number 7 says, write the above reaction using chemical formulas. That's what I just said. Copper plus silver nitrate yields silver. Ag is silver, by the way, if you haven't figured that out. Why is Ag silver? Well, it comes from the Greek word for silver, whatever that is. I don't know what it is. I just know that, that when a symbol from the periodic table doesn't make sense, it's because they're using the Greek word. Could be different, actually. I want to say some of the elements were discovered in Poland. Some of them were discovered in Russia. So it could even be different languages other than that. But a lot of the symbols don't make sense because they're using the Greek word for that element. All right, so there's 2 chemical equations there. I did the chemical symbols for one and the chemical formulas. And then for the other one, I just used the names of those chemicals. Most of the time, you can do it either way, but there may be times when I ask you for one or the other. All right, great job, everyone. And now I hope you feel like you can identify chemical reactions, explain the difference between chemical properties and physical properties, the difference between physical changes and chemical changes. And I hope you can just be really proud that you understand a lot more about this stuff. All right, see you later.